Welcome you all. Myself Nagarajan, Assistant Professor in Department of EC at Rohini College of Engineering and Technology. In this video, let us see the optical communication. Second unit, second topic is the absorption losses. Already we discussed that is the attenuation losses. Now let us see the absorption losses. Absorption losses, after completion of this video, student will be able to understand the absorption. Absorption by atomic defect. Let us see the definition of the absorption loss. Absorption loss is related to the material composition and fabrication process of fiber. Absorption loss results in dissipation of some optical power as a heat in the fiber cable. Glass fibers are extremely pure. Some impurities still remain as residue after purification. The amount of absorption by these impurities depend on their concentration and light wavelength. Absorption is caused by three different mechanisms. First one is absorption by atomic defects in glass composition, extrinsic absorption by impurity atoms in glass matter, intrinsic absorption by basic constituents atom of fiber. So absorption by atomic defects. So atomic defects are imperfections in the atomic structure of the fiber material, such as the missing molecules, high density clusters of atom groups. These absorption losses are negligible compared with intrinsic and extrinsic losses. The absorption effect is most significant when fiber is exposed to ionizing radiation in nuclear reactor, medical therapy, space missions, etc. The radiation damages the internal structure of fiber. The damages are proportional to the intensity of ionizing particles. This result is increasing attenuation due to atomic defects and absorption optical energy. The total dose the material receives expressed in ray or silicon. This is in the unit for measuring radiation absorbed in bulk silicon. 1 radian is equal to 0.01 joule per kg. Higher the radiation intensity, more the attenuation. This is the ionizing radiation intensity with fiber attenuation. This is the radiation intensity in the x-axis, radiation intensity, and y-axis we are considering fiber attenuation. So it is gradually increase when radiation intensity increases. Absorption. The extrinsic absorption is due to impurities present in the fiber material, such as the transition metal impurities, OH ions. Extrinsic absorption occurs due to the electronic transition between the energy levels and because of charge transition from one ion to another. A major source of attention is from transition of metal impurity ions, such as the iron, chromium, cobalt and copper. These losses can be up to 1 to 10 decibel per kilometer. The effect of metallic impurities can be reduced by glass refining technique. Another major extrinsic loss is caused by absorption due to OH ions. Impurity dissolved in glass. The vibration occur at wavelength between the 2.7 and 4.2 pm. The absorption peaks occurs as 1400 and 950 and 750 nanometer, first, second and third overnodes respectively. And following figure shows the absorption spectrum of OH group in silica. Between these absorption peaks there are a region of low attenuation in a OH absorption. Intrinsic absorption occurs when material uses the absolutely pure state, no density variation and inhomogeneity. Intrinsic absorption sets the fundamental lower limit on absorption for any particular material. So intrinsic absorption results from electronic absorption bands in UV regions and from atomic vibration band in the near infrared region. In the infrared region above 1.2, the optical waveguide loss is determined by the presence of the OH ion and inherent IR absorption of the consistent material. So inherent IR absorption is due to the interaction between the vibrating band and the electromagnetic field of the optical signal. This result is transfer of energy from field to the band, thereby giving rise to absorption. This absorption is strong because of many bonds present in the fiber. Attenuation spectra for the intrinsic loss mechanism is pure. Germanium is shown in figure. Ultrasonic losses at any wavelength is the equation for ultraviolet loss at the wavelength. X is a mole fraction of germanium oxide, lambda is the operating wavelength, and alpha ultraviolet is in decibel. The losses in infrared region is given by 7.81 into 10 power 11 e power minus 48.48 divided by review questions. Attenuation and losses in fiber, attenuation mechanism in the optical fiber, discuss about the absorption losses in optical fibers, and compare and contrast the intrinsic and extrinsic absorption mechanism. Students, all of you understood about the absorption losses. Thank you.